Okay, triple check that your capital B does not look exactly like your scripty B. This guy is a matrix, and this guy is a set of vectors, a finite set of vectors. Okay, now we will notice that every basis of R2 has exactly two vectors. That is because this matrix B has to be square. And if you think about it, the number 2 isn't special. Every basis of Rn has exactly n vectors, period. Okay, so this is true for R2, R3, R4, Rn, but one can show further that it's true for any subspace, in fact. Okay, so what I'm saying is that if I have a subspace U, and I say I find one basis of that subspace, and I find a second subbasis of that subspace, well, they must have the same number of vectors. Okay, so what is true for Rn? Turns out, with some proof, to carry over to any subspace of U. Okay, so this is a number we get. We get the number of vectors in any basis. So m is equal to k, and we call this the dimension of U. And our short form is just dim U. So what is the dimension of U? The dimension of U is, well, I look at a basis of U, and I just count how many vectors are in that basis. Okay, this is formalized in the following definition here. So copy this into your notes. So now the dimension. Let's do some examples to illuminate. Let's look at dimension of R2 itself. Well, we said above that a basis is 1, 0, 0, 1. Now this set here, two vectors in that set. So the dimension of R2 is exactly 2. So again, to find a dimension, you find a basis, and just count how many vectors are in there. What about dim Rn? Well, Rn, you have a more complicated basis. You can probably guess that this is going to be n, but to see it in more detail, we can look at a basis. We do what's called the standard basis. We do 1, 0, 0, dot, 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 all the way to 0, comma. The next one will be 0, 1, 0, then the rest are zeros. And you continue in this way until you get to the dude, who has a 1 down here, and the rest of it is zeros. And this has n vectors. This basis has n vectors. So dimension of Rn is n.